Hello, everybody. Hello, GM. How are you doing? Wishing you all happy afternoon, morning, or evening, depending on where you are. It's definitely afternoon in Europe. Happy to have you all here, and welcome to our Wednesday's workshops. Today we're going to have two workshops. It's going to be a busy day full of a lot of interesting content. Starting off, I'm just quickly going to invite Ege on stage, who's going to be our speaker for today, and we're going to go through mental models for ZKML and all its applications. Um, Today's session is going to go through not too different than yesterday's. Again, we're doing presenting, and we deeply encourage you all to go through, to listen carefully, and there's going to be a lot of new interesting contents that are going to be presented. So please make use of the questions tab. It's a small button towards the lower right side on your screens, and you will be able to post your questions. I will be reading them out loud to Ege, who's going to be providing you additional information based on what you're saying. Other than that, a quick reminder that if you have not yet found yourself a team, you can still look for one. We have the developer board up and running, so feel free to browse the profiles of like-minded people that are trying to build something new, experimenting with new tech. So feel free to find someone to share the burden of creating something new, because that can be a challenging thing to do. Other than that, also don't forget that there is a dedicated idea submission form that you will have to fill out before the end of the week, because the Giza team would really like to know what you intend to build, based on what you're planning to build, and based on how feasible it is, on the amount of work support that you might need. They will work closely with you. They will even try to assign people to have calls with you one-on-one, and we will also be doing so from the Encode side to try and give you the support needed to end up building up your idea before the end of this 3-week hackathon. It's not that much time, so hopefully you will find the time to organize properly to submit before the end. But enough of me. Ege, lovely to have you here. We've had some issues in the lead up to the call, but these have been alleviated ever since. But yes, lovely to have you here. And yeah, feel free to share screen and take it away.
Thank you so much, Yasin. First of all, thank you everyone for coming. As Yasin also said, I think especially for this workshop, it's really important that you guys actually ask questions, because this is not going to be, me just explaining how Giza works, etc. This is more of a theoretical sort of discussion about ZKML in general. So this won't necessarily delve deep into the technical side of things. This will also not be a discussion strictly about Giza and its products, but this is going to be more of a sort of discussion about the theoretical sort of application space of ZKML in general. Obviously, this Gizathon is specifically designed for agents, and that's also going to be the main portion of my sort of presentation. But we'll first sort of start with a general introduction of what ZKML is, its application space, in Web 2, Web 3, and then at the end, we'll go directly and deep into the agent side of things. So let me quickly share my screen. I hope everyone can see it.
Yes, perfectly visible.
Awesome. So again, thank you all for coming. And yeah, here with this presentation, the hope is to give you a more sort of methodological understanding of how ZKML actually applies to real-world challenges and problems. But first of all, quickly introducing Giza. Obviously, if you're here, you already know what Giza does. Essentially, we're building open source verifiable ZKML infrastructure. But obviously, the question is, what is verifiable ML or what is ZKML? So you can look at a ML model in very different perspectives. But I think to understand ZKML, the best sort of approach is the most simplest and the most sort of, the most easy to understand approach, I believe. Any machine learning model, in essence, is just a pipeline of operations, right? You have a input data, which is usually like a high dimensional tensor or array, and you feed it into this model, which essentially does different matrix sort of operations on it until you get an output. Obviously, this is a very sort of simplified version of what's happening. There are temporal models, there are attention models, which don't do like a direct 0 to 1 approach, but they do looping, etc. But in essence, it's just a program that does arbitrary operations on some high dimensional input. In the case of deterministic sort of models, you have the input and you have the model itself, its architecture and model parameters, and you feed it and you always get the same output. With non-deterministic models, LLMs, ChatGPT is a good example of that. For example, like what does non-determinism mean here? You can ask the same question to the same ChatGPT model and you would get a different result, right? And that can cause you to say, okay, well, what's happening here? This is not deterministic. Like, how can we infer anything? Or if it's a program, how can we prove this program because the output is random? But if you look more closely, it's not actually random. What you're having is a random sample from a deterministic distribution of outputs, right? So if you ask the same prompt, let's say 1,000 times, you'll see that some of the answers are going to come out more often than others. And if you do it like millions of times, you'll actually be able to understand the exact distribution of outputs. So even though the output you see is not deterministic, the underlying distribution is deterministic. And this is good because in ZKML, what you're essentially trying to prove is that when you have this input and this model architecture, you get this deterministic either output or distribution of outputs. And what we are proving is essentially this program, right? How do we do that? We use Cairo. Cairo is a generalized Turing-complete provable language developed by Starkware. And on top of Cairo, we have our own sort of ZKML specific library called Orion. And in this Orion library, what we have, you can think of it like a good analogy for me is, let's say you have Python, but you add NumPy or you add PyTorch on top of it, right? So it's a more ML-specific library, which that uses its own like numbers, tensors, matrix operators, etc. So how do we get the proof here? We essentially look at this program, this model as a program, and we compute the start. It can be any type of like computational proof here. You can use different things. Because we are using Cairo, we are inherently using starts. We're essentially proving the correctness of this program, which gives us the proof of inference. Obviously, we can also talk about proof of training later on. We are not doing proof of training, but I think in the future that will also be a very, very important sort of product and also its use cases, where in that case, the output wouldn't necessarily be the output you get from the model, but it will be the new sort of updated model parameters that you would get. So the input and the model architectures here would swap their positions. So before I go, Yasin, are there any questions? I cannot see the...
No, all good, no questions so far.
Good, awesome. So with that line, we come to our first, I would say like space of, or like branch of use cases, which is regulation, right? Because since we have right now the ability to prove that this input and this model architecture leads to this output, we can do certain things that are very relevant for the regulatory sort of branches. What does that mean? We can actually prove that the output, which is usually critical in the fields that I'm going to talk, such as health, military, etc., actually comes from these inputs and this model architecture. What that means is perhaps some models and some architecture are either whitelisted or blacklisted in some regulatory branch, with this proof of inference, you can actually prove that you use the correct sort of type of model and not the other one, right? Another problem or another solution would be where, for example, for credit scoring, where you want to prove that you actually not manipulated the output at all. So you have a model that is perhaps subscribed to some system, and you need to prove to either users or the regulatory branch that you are using this model, and so the correct model. And once you actually give as input, user data, that you actually get the correct credit score that you shown to the user as well. Another sort of, I think, tangential to AI regulation is the concept of privacy, where obviously because it's a ZKML proof, you can actually choose which data you want to show, right? Perhaps you don't want to show the model parameters and or you don't want to show the input itself. You have the freedom to do so, right? For example, AI competitions, I believe, is a great example of that. I've been to like many competitions before, and it's always sort of interesting to say, okay, I want to prove that my model is actually, exceeds this amount of, let's say, accuracy threshold that I need to do. However, I don't want to share my model, or I don't want to, perhaps I want to share my model parameters, my model architecture, but I don't want to share my model parameters, right? With the ZK sort of proof system, you do have the ability to say, yes, these are the data that I want to share, and these are my proprietary data that I actually don't want to share. Good examples here are, as I said, AI competitions, but also finance, I believe, is a great sort of example of that, where perhaps you want to prove to some user that you have this sort of metric or data for them, but you don't want to share their entire input to them. So the way I think about it is that these two just leverage the ZK and the proving part of the ZKML sort of paradigm. But there is another sort of aspect to it, I think, which makes it very much interesting, which sort of deals with computational complexities. Now, I don't want this talk to be very sort of low level. I want to keep it a bit high level as possible. So I'm not going to delve deep into all the details or like ON, notation of different proofs, etc. But generally speaking, sort of the comparison you see right now is a good benchmark to sort of understand how complexities of different sort of operations actually work. What do we look at? We have proof generation, which is more complex than inference, or more computational expensive is another way to describe it. So proof generation is more expensive than inference, which is much more expensive than proof verification. What does that mean? The inference you see in the middle is just, without any ZK sort of system, just naively running the model. The alternative to that would be in a ZKML system would be obviously that you generate the proof and then you verify the proof. So if you compare inference to proof generation plus proof verification, inference is cheaper, right? So if you're, for example, in your local computer, right, you either just run the model on its own, or you first generate the proof and verify it. Obviously, generating the proof and verification is more expensive. So there is no reason to do that, right? Just running the model naively is cheaper. However, if so this is exactly what I mean. We're in the same sort of execution environment. We either generate the proof and verify it, or we just naively run the inference. However, and this deals with sort of asymmetrical sort of efficiencies of different computational environments. If there are two different realms where in one sort of place the computation is actually cheap, but in the other one it's expensive, there is a trick you can do to make the entire system cheaper in terms of efficiency, in terms of computational efficiency, in comparison to actually running the model. What do I mean by that? Is that since generating the proof, yes, is more expensive, but verifying the proof is actually cheaper than inference, What you can do is you can generate the proof where computation is cheap, right? This can be some cloud server. It's a complex, it's a sort of like an expensive computation, but you do it where computation is cheap. And then you send the proof where the computation is actually expensive, right? In that case, what you're comparing that to is running the inference naively where the computation is expensive. And because verification is cheaper than inference itself, it turns out that the entire system is actually cheaper, right? So generate it, I think it on its own, like intuitive why it makes sense. You generate the proof where it's expensive, where it's cheap, and then you send it where it's expensive. What are good examples of that? What are, or in other words, what are good sort of spaces where you have this computational asymmetry? Obviously blockchains, as well as edge computing, right? Blockchains are sort of infamously expensive to do computation on, right? You know, you can always run a model on a blockchain. However, that would be extremely expensive because machine learning models are, you know, complex sort of computations. Another example to that would be edge computing, right? You can have, like in some IoT network, etc., you can have little computers everywhere in the physical world, and you can actually try to do sort of ML models there, but that would be very, very expensive. Rather than doing that, what you can do, which is what we're doing with blockchain agents, as a hint I can give you that, is that we do the inference where in our cloud, right, where it's actually cheap to do so. And then we only send the proof on chain. And so rather than doing running the entire model on chain, you just send the proof there and you just do the proof verification there, which is exponentially cheaper than actually running the model there. Yassine, do we have any questions regarding the last two slides?
No, not at the moment.
Okay, awesome. And then we come to the actual meat of the subject, which is Giza Agents. So the way I see it is that Giza Agents doesn't necessarily change the application space of things. However, it allows you to essentially host that service or realize that service in a different manner, right? This is a sort of like a copy of a slide I used in a previous presentation, essentially talking about the important properties of Giza Agents. And we can quickly have a look at that. Permissionless, right? You are the owner of your agent's wallet. What that means is that we as Giza do not have access to your private key. That's your agent. That's what you're doing. We also, I think this is the most important part, because of the agents, and I can, you know, quickly explain why we decided to go with the agents. Because before agents, we were actually trying to like create these, you know, smart decentralized exchanges, you know, smart vaults, etc. And the problem and the sort of the position of the friction was always where, okay, we need to come up with a new AMM architecture, right? Where that would include some endpoint to some ZKML model, etc. This obviously takes a toll because you always need to ask the protocol side to change certain things. With agents, these are completely protocol agnostic in the sense that you can create an agent, and because these agents are, you know, these sort of self-entitled sort of entities, they obviously interact with the protocols, they interact with the pools, the decentralized exchanges, etc. But these exchanges don't necessarily need to change in terms of, you know, architecture, in terms of software by any means, because from their perspective, they're just, you know, doing trades with another wallet, right? So I think this is really, really important, because if you have an idea, you can simply implement it. You don't need to change the protocol that you're building on, which is a huge advantage. Another property is auditability, which essentially means because it's ZKML, you can actually trace the entire sort of, you know, from inference, from input, inference, action. You can see if there's an error, where the error happens. Obviously, we'll go deeper later on, but, you know, the model owner can be a different entity than the agent owner, which can be a different entity than the protocol, etc. So the auditability allows everyone to essentially have a trust minimized relationship with the other agents in the system. Another, I think, really important aspect in terms of the machine learning side of things is that it's an evolving product, right? You can have an agent and can initially have a ML model linked to it. But obviously, since it's doing action, it's generating new data. And we have sort of essentially designed the agent system in such a way that with those data, new data that you have created, you can always have like a feedback loop where you can sort of iteratively improve the model, which then will improve the agent, the action, which will create new data, etc. So we believe it's sort of like an evolving product that will get better as it generates new data, essentially. And obviously, one other technical aspect is because we are using Ape as the sort of underlying wallet framework, you can use it in many different agents, in many different blockchains, right? So this allows us to be as free as we can because we can create new agents in essentially any protocol in most of the networks that we want.
Two questions that
Yes.
came in. The first one is from Satya. She's asking where exactly at runtime are these agents running?
Can you ask the question again?
Where exactly runtime are these agents running?
Yeah, so right now, if you do, like, there are different options there. Right now, what's happening is that we have like these agents as essentially running in our Google Cloud. But if you, like, we offer also extra services to these like different enterprises where if you don't want to have the agent running in our Google Cloud, you also have the ability to run in your cloud or wherever you want. But currently, when you're running in our Google Cloud service.
And an additional question that is from Mahmoud, who's asking, can you explain what is exactly an agent? Because there's an entire narrative related to LLM agents, and are Giza agents also inclusive to LLM agents?
I think that's a perfect question. And I completely agree with you. I just was participating in like an agent sort of conference in Berlin 2 days ago, actually. And I had the same questions asked many, many times over, which is obviously right now there's a huge sort of popularity. You know, there's a lot of interest in like agents in general. But when people are talking about agents, they're generally talking about sort of LLM supported sort of systems, which essentially allow you to not only, you know, use LLM to ask a question and give its answer, but it can actually do actionable things in the physical world, right? So in the conventional sort of understanding of what an agent is that it's some entity which perhaps you're asking, you know, what's the best restaurant in Berlin? And not only it gives you the answer, you know, like ChatGPT would, but it also has the ability to then say, okay, let me book this restaurant for you, right? So not only it gives you the answer, it can actually interact with other sort of software entities in the world. What we're looking at when we are talking about Giza agents, we're not necessarily talking about an LLM, while that can be applied, and I'll talk about it later. We're essentially talking about a ZKML agent. And I think that distinction is very important, right? What's a ZKML agent and what's the difference than a conventional LLM agent? Here, it's less about, you know, having this like very smart agent that is able to act for you, because these are a bit more like focused products where you know what you want to do and you build the model specifically for that task. But the fact is that once you have the model, the endpoint, the agent developed, what can happen is that there can be another person, another user that is not the model developer that can use your agent to do certain actions. And because it's actually verified, right? So because it's a ZKML system, if you know the model, if you know what the task is, you can actually use that agent to perform certain actions, and know that the agent only does certain things when the output of the inference is actually verified. So for me, it's more of an agent in the sense that it's this entity that is able to self-verify everything it does, make sure that everything is correct, and only acts on-chain when the verification is complete. So it's this like self-correcting and self sort of this system that is able to essentially create a trust minimized sort of environment for every agent in the system in general.
A couple of more questions coming in from
Yes.
Sadia. So one of them is, so you just want to confirm so that agents are basically running off-chain that can run on your cloud, or are they whitelisted VPCs on client clouds or data centers?
So can I, for some reason, I cannot hear some of the words you say. Can you repeat it again?
Okay, so Sadia is asking, are agents running off-chain that can run on your cloud or whitelisted VPCs on client cloud or data centers?
Yes, you can theoretically build those agents as well. Like currently, I mean, here the problem is that we also need to talk about what you guys have access to right now, right? Because like this is meant to be more of a theoretical sort of presentation, but I also want to guide you towards what you can actually build with your ideas in this Gizathon. I would suggest that you only do sort of you only build agents assuming that you would run on our cloud service. You can build that, and we have partners where we are essentially trying to build agents on their cloud services. But I think, speaking realistically for this hackathon, it's better to assume that you will build these agents on our service, right? On our Google Cloud service.
Perfect. Gonzalo from your team is also answering other questions, so it's in chat. So I think we can move on with the next slides.
That's awesome. Yeah. So again, delving deep into Giza Agents, and this is also a slide that is meant to explain the LLM sort of question that came before. What makes Giza Agents special? How are they different from like other agent systems? As you guys probably are aware, like there are also LLM-based agents that are able to run on-chain, so like Web3 agents, or can have like interactions with Web3 stuff, with Web3 protocols. The problem here is that what we are doing is we're leveraging the zero knowledge property of Giza Agents, right? So there's a social aspect to that, where you're not only using the output of inference to do something, right? You can do that with a bot as well. How the Giza agent sort of distinguishes itself from a bot system or some LLM-based off-chain sort of agent is that we are essentially putting the data on-chain only when it's verified. And we essentially create this environment of what I believe is 4 different agents or 4 different roles. You have the model developer, the person who's actually building the model that is going to use for the agent. We have the agent developer, who's probably building the on-chain sort of interactions, what the agent will do, which contracts it will interact, etc. We have the protocol, which is the protocol of whatever smart contracts the agent will interact with. And we have the agent user, right? That can be you or me. That can be, the model developer itself, but that can be just some other person who has no idea how the model was developed or the agent was developed, but just want to use that agent for his or her own benefit. What I believe Giza agent does perfectly is that it allows everyone to have essentially his or her own niche, while making sure that there's no space for anyone to deceive any of the other agents in a trust minimized setting. What do I mean by that is, obviously you can have a bot, right? That does, that does some inferences off chain and does certain, let's say like trade swaps, etc. If you have, and here I want to be like a bit more realistic and a bit more sort of concrete about which sort of ideas I believe make more sense than others in terms of a ZKML agent. is that, for example, if you want to have a trading bot, right, or like some trading agent that does, that looks at market data to then perhaps do some swaps on chain. If that's going to be an individual agent, right, you want only yourself to, you're the one who's building, you're the one who's going to use. I don't think Giza or ZKML in general makes a lot of sense. Why? Because you're essentially, as I told before, paying extra for no benefit, right? Proof generation, proof verification, these are essentially more expensive in comparison to naively running the agent, and you're not leveraging the ZKML aspect in any means. However, how can we change that sort of idea to make it more a better suite for ZKML would be if you would have this, let's say, vault or this like trading agent that actually collects tokens from other people, right? So it's an open sort of public agent. You are the one who's developing the models. Perhaps you're the one who's also writing the agent logic. But there are other people who are interested in your product and you want to be open with them, right? What you can do with Giza Agents is that you can say, okay, guys, here is my model. Here's my agent. You can put your tokens here. And I make sure that I am not going to lie about the output of my agent to perhaps, use your tokens for my benefit or lie about any of the stuff I do in any ways. No, everything will only sort of interact with on-chain contracts, only if it's verified, only if you can know that I use the correct model with the correct agent, etc. In that case, the user of that agent can believe, okay, I don't need to trust this person. I can just use his or her agent and benefit from it, right? Essentially, what that means is it opens this like new social paradigm of machine learning developers who can create these like interesting sort of logics and agents on chain, and other people not naively but knowingly believing them and going with their agent. The other part of the paradigm, in my opinion, in terms of identifying use cases for ZKML in general, is how can we identify ML use cases, right? Because currently, as you're also probably aware, smart contracts or like Web3 related stuff, generally speaking, don't necessarily use any complex or even simple models. There's a very obvious reason for that. As we said, computation on blockchains are generally very expensive. You cannot run a model on chain. It would be extremely expensive. However, with this new ZKML paradigm, you're actually being able to perhaps not run models on chain, but you're able to leverage the output of the inferences on chain, which essentially means that you can use machine learning sort of powered or like you can leverage machine learning on chain. However, as this is also sort of a result of many trials and sort of challenges, not every task is a good machine learning task. And here I essentially listed 3 sort of important points or like checklists that needs to be checked to make sure that, okay, we actually have a good machine learning case here. The first one is high dimensional input space. What do I mean? You can try to build an ML model for any task, but you're actually going to see that for a lot of these tasks that, a simple, more sort of essentially a simple computation or a rule-based system is efficient or is good enough, right? You don't need ML to do everything. How can we know that ML would be good or better than a rule-based approach? Well, obviously, there are like, it's impossible to methodologically say this is better than this in some tasks. But generally speaking, if the input space is high dimensional, meaning that it's not just 2 numbers, but it's a lot of like different numbers, different markets, perhaps like different historical data, etc. Rule-based systems begin to underperform, and ML sort of models start to be better because models in general are much better at understanding which data is important and which data is not, where rule-based systems, built by humans, they're usually much worse at that. So if there's a high dimensional input space, meaning this task requires you to look at a lot of different data with a lot of different complexities, ML can be a good fit there. Another sort of very, very important sort of checklist element to check is, are there existing data for what I want to develop, right? People have a lot of different ideas. They're always really interesting, but you cannot essentially develop a model if you don't have the data for it. And blockchain is great because you essentially have all the data related to blockchains, right? You can get any data that you want. But speaking from experience and if you look at the reality, a lot of this data is sometimes very hard to find. Sometimes it's extremely messy. Sometimes they don't just store that type of data. So I would urge you to, whatever model that you want to build, make sure beforehand that there's data. So do this like data feasibility check or whatever, where you actually are sure that you have the data for whatever model that you want to develop. The other part, which I guess is somewhat deals with what we have talked before, is that okay, you have a model and you're doing some inference with it. Do you need to verify that inference, right? As I said, if you're doing an individual market bot, you don't need to verify that inference because you're doing it only for yourself. There's no other person whom you're trying to convince or something. In that case, you don't need ZKML. However, if there are multiple parties with different incentives, with different sort of needs and requirements, there I believe ZKML actually fits much better. Yeah, so that was essentially my slides. I'm open to questions right now.
Yes. Do you want me to read them out, or
I don't know perhaps I can.
Yeah, I don't know if we want to be sharing anymore.
Let me quickly close. Yes, I can read it for you. So where are we?
So the only two questions from Juanito and Fanfa are the ones that need to be answered.
So I'm seeing Fafa's question, which is, I'm unable to find the recording from last session. I don't think that's what you're referring, right?
If you scroll all the way up to like those we've already covered.
Gotcha. Right,
so
now I see.
The question from Fulanito and then from Fanfa.
Awesome. So Fulanito asks, can an agent only take a prediction from a transpiled model, or can it take it equally from an algorithm created with Giza IA actions? What do you mean by IA actions? That's not something that I'm familiar with, Fulanito. So my sort of theory on your question is that, does it need to be a model, right? Can it be something, etc.? Oh, sorry. Can you guys hear me?
Can you hear me?
Yes, I can.
Okay.
I think my speaker was just out of charge. Yeah, so essentially what we do is you can theoretically create any type of like Cairo program, and you would be able to then, oh, sorry guys, my bad. Yeah, so if you have a Cairo program, you can technically sort of run it in our system. We do have a few examples with that. However, that would necessitate that you would write the Cairo program on its own. And obviously you need to know Cairo with that. Using our transpiler, you can essentially create any type of model, in PyTorch, in TensorFlow, etc. And we do the translation on our own, meaning that you don't need to care about, what Cairo, what provability, everything is abstracted. So what do I mean, or what it comes down to, is that I would heavily suggest you to use a model for that. You can technically do non-ML based sort of programs, but that would necessitate you to use Cairo.
We have the question from Fanfa, which is, would these agents be vulnerable to being front-running in the traditional sense? Who is actually handling the forwarding of transactions to being executed for the agents? This can create a new sense of MAV to front-run specifically Giza agents. Correct me if I'm wrong. No, you're absolutely right. Like right now, there's no different protection for Giza agents. So it's essentially just a transaction from the eyes of from the eyes of the protocol or from the eyes of the blockchain in general. So these can be MAV run if someone intends to do so. If you want to do something a bit more, let's say like high frequencies swapping or whatever, you would be responsible for the MAV protection in regards to that. But there are some protocols, etc., that do this inherently. So if you're building something like that, I would suggest you to look at the other types of protocols that do these MAV protections much better. We have Satya Krishnami, who's asking, can you touch a bit on the formats? Is there an Onyx overhead? So let me also quickly go to that. What's Onyx? Onyx is essentially like an intermediate representation of any type of ML model. What I mean by that is, I don't know how many of you guys actually used it, but it's essentially a way to, let's say you have a PyTorch program or model, you have a TensorFlow model, etc. You can actually convert any of these different frameworks to an Onyx framework and then to any other framework, right? So it allows you to do that transition. How we leverage Onyx is that we use it as this like intermediary sort of representation of the model, which we can then use to then transpile, right? So rather than writing a transpiler for both PyTorch, TensorFlow, etc., we just have a transpiler for Onyx. So that allows us to that allows us to essentially abstract away all the complexities of these individual frameworks. Is there an Onyx overhead? Not necessarily, because you're not using Onyx. Onyx is just a way for us to then transpile into a Cairo program, into a area representation, etc. So there is an Onyx overhead. We believe that there are better ways to do this translation in the future, because Onyx has some inefficiencies, especially for certain model architectures. But in terms of the performance you get from the agent at the end, there is no necessarily overhead from Onyx. They asked, is it possible to train model on Go with new data? Yes. So what you can do is you can retrain the model, and then that would create like a new version of the model, of the endpoint, and then you would attach the new version of the model to your agent. So yes, you can absolutely do that. Satya Krishnami asked, is it right to say the combination Giza proves is public data, public model to other verifiers, and other combinations? Public data, private private model, and private data, private model are not things possible now. So here is sort of the reason I disclaimed I'm going to talk about the general high-level point of view of ZKML and not exactly our product, because, for example, right now, the data that you use cannot be private. It needs to be public because that's in the proof. Later on, as I said, and I think Rafael also mentioned it in the previous meeting we had, we are building like a Noir extension of our product, which will then enable us to use private data, but currently only public data. What are the private keys stored? Where are the private keys stored for these agents? Are they obfuscated by ZK proof? So if you look at the tutorials, that will become much easier to understand. But essentially, when you create an agent, you need to have an ape wallet. And when you create the ape wallet, you will create a private key that will be stored on your local computer. So it doesn't need to be obfuscated because we do not have access to to that proof at all. That's stored in your local computer, and that is created when you create the ape user, either as Noir extension from Aztec protocol. I'm not actually sure which protocol does Noir. I can have a look. Maybe Gonzalo or Rafael, if they're in chat, can answer that question, like where it comes from. Okay, I think it's Noir this time. Satya asks, just conceptually, what is the difference in successiveness in what Giza does to snarks? In other words, what is the extra steps in interactive steps? So I'm not an expert in these sort of, intricate differences in terms of like different computational proofs. I think Rafael would be a much better person to ask that question. So I'm not going to show my ignorance. I'm just not going to answer that question.
Yeah, I just wanted to quickly add, if any of our speakers don't and cannot answer some of your questions, the Giza team, pretty much all of them have joined our Discord. So make sure to post your questions on Discord, and you will get responses in a real quick amount of time. So you don't have to restrict yourself to asking questions just live. Please use the Discord both for technical and other questions, and we'll try and help you out as soon as we can.
Thank you.
Yeah, there's another question from Ali.
Yeah, I see. So another question, when creating a new agent, developers are directly in charge of the private key of the new agents we spin up on our local machine. The developers are directly in charge of the private key of the new agent we spin up. What do you mean by the developers? Do you mean you or someone, some other, or do you mean us? So yes, exactly. So if you're the developer, you're building an agent. To build an agent, you need to create an ape wallet. When creating the ape wallet, you get the private key, and that's your private key. You're in charge of that private key. Satya asked one more question. Can you touch upon how the bounties relate to each other? This will help us to think about problems to work on. Relate to each other? I'm not sure how I would answer that. So like we have our own bounty, which essentially is a bit more like generalized. And there are these like specific bounties given by specific partners of ours. So you can either build like a more focused agent specifically for that bounty. Obviously there you like the task is already somewhat there. So it's a bit more sort of technical focused. But if you have, a cool idea that you want to build, you can also essentially use our Giza bounty, and that sort of is aimed to be a bit more general and where you can show your cool ideas.
Yeah, just to touch upon bounties, there are multiple ways with which you can participate. So you can basically pick a single bounty, or you can try and be creative and find some sort of synergies between different products, utilizing the Giza stack to have a solution that kind of like builds for multiple of them. That's going to be quite hard, but still, who are we to stop you and your creativeness as well? So if you feel you're onto something, utilize the Giza stack to the best way that you can. Share your idea. So if you have something in mind, that's what the Discord is for. That's why we have a very specific form. If you have something in mind, please check out the submission, the idea submission form. There are 3 really important things that your idea should be able to answer in order to qualify as a project that you can build upon during the hackathon. So please have a look at the form. Make sure that the idea that you have in mind is one that actually answers positively to all of these questions, and then make sure you submit it. The Giza team will have a look and will provide feedback accordingly.
Thank you, Yasin. I think there's one last question, not last perhaps, but is it possible to instantiate using the Giza Python SDK a new custom Giza bot agent written in Cairo? Written in Cairo? I don't think so. Maybe Gonzalo can answer that, but okay. To clarify the question further, is it possible to create a new custom model in Cairo and make it available to Python SDK? When you're talking about model, you're talking about an ML model or something else? Because how would you create a custom ML model in Cairo and then make it available in Python? I don't understand that question. Maybe Gonzalo has an idea. Where can we see this supported blockchains? Can the slides be available?
Yes, the slides will be made available after the after all of our workshops. All of the workshops are recorded, and the slides will be added to the Hacker Pack as well. Has been linked multiple times, and as I said, we keep on linking it in the announcement channel. It has been emailed to you with the onboarding emails, so make sure to have a look. It's really detailed, and we try to keep it full of all kinds of useful information. We just added additional links today and additional resources as we coordinate with the Giza team. So everything that you might be in need of is most probably inside that document. And other than that, always, as I said, make sure to post your questions in chat, and we'll try and help you out.
Absolutely. So Fafa asks, so implementing your own XGBoost model, but different model, for example. That was tied to, is it possible to create a new custom model in Cairo and make it available to Python SDK? So we're implementing our own XGBoost model in Cairo and then making it, yes. So yeah, absolutely. So if you don't want to do the translation step on your own, what you can do is you can essentially write a Cairo program, and I wonder if that works for every type of. I don't think that would work with our endpoints. I think that needs to be transpiled from us to then be integrated in the agent system. Gonzalo here can perhaps answer that more discreetly. We had some cases where we didn't hassle with the translation at all. We just directly written the Cairo model. But I think that would take us some effort from our side, and I'm not sure that would work. So I would suggest you to write the XGBoost model. By the way, we have recently created this like XGBoost model complexity reducer, basically, which means that if you are interested in building a model, we heavily urge you to create an XGBoost model if it fits. Because with XGBoost, what you're going to see, obviously, Rafael also mentioned it, but if you're trying to transpile a complex model, that sometimes gives some error, like there's a restriction in terms of the complexity of the models. With XGBoost models, because of that complexity reducer, even if your initial model is complex, we are able to reduce its complexity to a degree where we can actually transpile it. So if you have an XGBoost idea, just implement it in Python, and you can easily use that model complexity reducer to then transpile it. So I don't think that is necessary for you to write the XGBoost model in Cairo, and I don't think that would be easy, by the way. Yes, I think that's all right. By the way, if you have questions regarding to these more backend side of things, Gonzalo is definitely the right person to answer those. But if you have questions in regards to more the use cases, application, does this make sense, etc., I would love to answer those questions in the Discord.
Amazing. In the meantime, maybe Ege, I can share a screen for a second just so I can showcase something. And let me show you the ideation form, which I've been talking about. It is the Agents Gizathon idea submission form, as I said. So this form has been shared to you multiple times over the Discord. I will share this again in the chat just in a second, but I just wanted to highlight the 3 questions that your idea should be answering positively to submit it so that it's a valid one. So you need to make sure that your agent idea is containing machine learning, needs ZK, and is actionable. You also you need to make sure that it's possible to obtain the necessary data to build the model, and it also has to be a feasible problem for an ML model. So these are the 3 really important questions that your idea should be able to answer. And as you end up submitting the form, these are just general information that has been already emailed to you, nothing too specific, but just more description of what you plan to build. But the general 3 things at the very beginning, as you look into your idea, should be these 3 questions. After your idea is answering positively to all 3 of them, you can then move on to to submit all the additional details. That's like, as you can see here, like feasibility requirements, what is data model requirements, agent scope, etc., etc. I'm going to be sharing that link in chat, but you, as I said, you should be able to find this form linked to you both over email multiple times as well as in the announcement channel. We make sure to communicate that on a daily basis because this form needs to be filled out before the end of the week. You don't have to do it right now. There's going to be other workshops, including one more today in exactly an hour, but make sure to kind of like explore, see what's required, and ideate according to the requirements of the Giza team, and they will then and next week we'll coordinate on the next steps. Yeah. Sorry to kind of intrude in here, but Ege. But yeah, any closing words from your end?
Not really. Thank you everyone for coming. As I said, you can always contact me in Discord. I think that will be, and I think generally speaking, it's really useful to have like a, in our past hackathons, we did like a 15-minute sort of feasibility check call. So if you want to have like, if you have an idea and you want me to check it, you can just book me like a 15-minute call where we can go over your idea, or I can do it in that document as well. But I think it's really important that the idea on its own makes sense. Obviously, implementation is very crucial, but it doesn't mean much if the idea doesn't make sense. So I think, take your time with the idea, make sure that it fits to the general criteria.
Perfect. All right. Thank you, Ege, and also thank you, Gonzalo, for being such an amazing support in chat. So many questions. You've been really, really helpful, and yeah, a lot of questions were asked as well, responded to. But yeah, thank you all for being here again. Tune in an hour, because this was, as I said, just the very first workshop for the day. But in an hour, we will be tuning in for fundamentals of on-chain agents, which is going to be a presentation from Jakub from the Giza team. So there's more to come. A 1 hour pause, and see you all in an hour.